So this rolling update strategy is the default strategy for Kubernetes deployment. This update works by gradually replacing existing pods using older versions with new pods having newer versions. Kubernetes gradually removes the existing pods one by one and replaces them with a new pod, one after the other, at the same time, without causing any downtime. In the manifest file, the strategy will specify rolling updates, maximum unavailability, and which you call max unavailable. We can set it at 25% depending on the number you want to set, and you have the maximum surge, which is also max surge. To explain this, max unavailability or max unavailable is the maximum number or percentage of pods unavailable at a time. So to say, if you have 4 pods and we've set our max unavailable at 1 or 25%, what it means is the number of pods that will be unavailable at a time. So you have 1 pod that's gone. And the maximum surge, which is max surge, is the maximum number or percentage of pods created at a time during an update. To also explain this at the same time is the number of new pods having new images that is created at the same time. So one pod is gone, a new pod is being brought in, another pod is gone, a new pod is being brought in, another pod is gone, a new pod is being brought in, and like that it is just continuous. So you can use number or percentage depending on how you want to run it. To trigger this, we would go straight to our manifest file. Let's delete our existing manifest or deployment and create a new one. So first off, we have this deleted, then I'm just going to delete this. Let me just do this. So now our previous deployment has been destroyed. Let's create the rolling updates deployment strategy. So to do that, we have our rolling updates, which is this, and we are using 10 replicas. So if you look at the manifest file, this is done, so this is just not useful. If you look at the manifest file, you can see the strategy that we're using, which is rolling updates, and the max surge is 25%, unavailable is 25%, and our replicas, we are using 10 replicas, the same node. So I would use green since our last is blue, so let's just use green. That's for the image, and the same pods, which is mapped on 8080, and the service account, I'm giving this, you are using load balancer, and it's mapped to 80 on the service. So for the selector, we are using app, and we are calling it node app, and the selector here, we are calling it node app. You could see that our label, the matching label selector, we are using node app. You could see that this is what we'll just need to create our deployments for rolling updates. Remember, this is the default strategy for Kubernetes deployment. So once you run it without this, you wouldn't need to bother yourself. It goes that way. So now to create, I would have to go back just a little bit, and then I will go into my rolling updates and run it. Alright, so once this is done, we'll give it some time for the load balancer to run. And start, since we are using load balancer. To confirm, okay, good. We have 10 pods. Let me clear this first. And give it some time for the load balancer. So this should be the load balancer. We'll create. What I will also do is I still have to create a new terminal so that we can see as the pods are being destroyed at the same time. So to do that, I would run kubectl get pods I just want you to see the pods run at the same time when it is being created. So the pods are running, and obviously I'll take you straight to see my application, if my application is ready. This is the old one. Since it is load balancer we are using, we wouldn't want to be sure that it is running properly. I think it's ready. Good. So now you can see our simple app is running. We'll go straight to updating the image. So to do that, what you need to do is to run kubectl set image deployments. So I will just have to change this. I'll just change it to blue and just do something that will make us see the replicas change. So now let's run this. You could see the pods are running and changing dynamically. Ooh, that was so fast. You see the new pods are running, and when we go straight to the web page, you could see it will start to change immediately. So this has 0 downtime, and you see the new pods are still terminating, the old pods are still terminating. When you go to the page, they are still terminating. So I think the new pods will be running right now. So now some of them are already running. I think all are running. So it has terminated all. So when we go and take a look at our pods, so we have all 10 pods. If you look back at the pods, the older one, we have different names, and then you look at the new ones. This just started 75 seconds ago, so this particular ones has been deleted. When you go to the web, you can actually see the changes has been made instantly. To repeat that same thing, I could also run it again, and you would see the changes. Let's make a change again. Let's just do something. I would edit this and change it back to green. So let's put it back to green, and see, once it runs, you would see this being destroyed, and you can see it's being destroyed. So let's just quickly go to the page. It's still there. The without any, you won't even know that something happened. So that's how it works, and this is actually the default settings. So moving on, we'll then go to the next stage.
Is the blue-green deployment. Thank you and see you next time. Bye.